This video cassette will introduce the viewer to the basics of screen printing. Screen printing is the oldest of all major printing processes. Based on the concept of the stencil, the process of forcing pigment through an image carrier can be traced back to ancient times. The Egyptians, Chinese, and Japanese used stencils reinforced with human hair. Silk fibers were later substituted for hair because of their greater strength. Lettering stencils like these are in common use. Note that small paper bridges hold the parts together. In 1907, Samuel Simon of Manchester, England, patented the idea of using loosely woven silk fabric to hold pieces of a stencil together. This allowed the small paper bridges to be eliminated, and the modern process of screen printing was born. Today, screen process printing is described by a variety of terms, including silkscreen, mitography, serigraphy, and selectine. The process utilizes power-operated flatbed and cylinder presses, as well as various types of hand-operated presses. Many specifically designed presses have been developed to print on flat, curved, cylindrical, and irregular shapes, and on a variety of materials, including paper, wood, textiles, glass and ceramic products, metal, rubber, rigid and non-rigid plastics, and fiberglass. Today, the screen printing process is used to print advertising displays, billboards, bolt fabrics, wallpaper, reflective decorations, as well as objects of every kind and surface. For hand production, the basic screen printing equipment is fairly simple, and the cost is considerably less than for other traditional printing processes. Screen frames for hand production can be purchased from commercial supply houses, or they can be built for specific jobs. Organdy is an inexpensive fabric that is frequently used in schools and businesses for work that does not require long runs or an extremely fine mesh screen. Silk, nylon, polyester, stainless steel mesh, and metallized polyester are other fabrics often used to make a screen. Some means of stretching the screen fabric is needed. Heavy-duty staples, tacks, or strips of heavy cord are often used for hand production. Screen stretching devices are available from several manufacturers. The types of stencils used for screen printing are generally grouped into categories depending on the method of preparation. The touche and glue method is an art process in which the design is painted directly on the screen. After the entire screen is coated with glue, the touche is dissolved, leaving that area open for printing. Hand-cut stencils include paper, which is adhered to the screen by the ink to be used in printing. And stencil film, which is bonded to the screen with solvent. Light-sensitive emulsions are either applied directly to the printing screen or purchased pre-coated on a support material and adhered to the screen after being exposed and developed. Stencil preparation will be discussed in another video. A variety of inks are available for screen printing. The selection of the correct ink for a particular job is based on the type of screen or stencils being used, the material being printed upon, the anticipated use of the final product, and the drying method to be utilized. Various cleansers, degreasers, and solvents are required depending upon the specific methods being used. A squeegee is used to move the ink across the screen, causing it to go through the openings of the stencil or image carrier. For hand use, the squeegee consists of a smooth strip of wood with a hard rubber or synthetic blade fastened to it. Several blade shapes have been developed for printing on different materials, and varying hardnesses or flexibility values are used to control ink coverage. A square-edged blade with medium hardness will meet most general needs. Some types of drying arrangement is necessary for screen printing because the ink deposit is too heavy to allow stacking of freshly printed materials. Printed sheets can be placed on wood or metal drying frames or rack arrangements. Textiles may be hung on clothes hangers on a line. For industrial use, various types of drying ovens and continuous conveyor belt dryers have been developed to speed the drying process. The screen printing process begins with the frame and the fabric attached to it. The frame, whether commercially produced or custom built by the printer, must be strong enough to hold the fabric without warping, deep enough to hold the amount of ink being printed, and at least 4 inches wider and longer than the stencil to be reproduced. Most custom-built frames are made of wood, usually white pine or poplar, because wood is relatively inexpensive and easy to cut to the needed dimensions. The high tension of modern synthetic fabrics, however, will warp wood frames unless the joints are carefully constructed to prevent this. Because of the tendency of wood to swell and shift when in contact with moisture, steel or aluminum frames are preferable where exact registration is a requirement. Threads that are woven to make screen fabric may be multifilament or monofilament. Multifilament threads are composed of several very thin strands that are twisted together to form a single strand. Fabrics made from these threads are designated by numbers ranging from 6 to 25. One or more X's used after the numbers denote the quality of the weave. 2 X's placed after the number designates the quality generally used for screen printing. Higher numbers like 25 represent finer weaves, which means a stencil with more detail can be adhered to the fabric. A thread number of 25 is equal to approximately 196 threads per linear inch. Lower numbers like 6 represent coarser weaves and have approximately 70 threads per linear inch. Monofilament fabrics are woven from single threads, and they can be woven much closer together. Monofilament fabrics with up to 500 threads per linear inch are available for screen printing. Fine halftone and other fine detailed stencils can be adhered to these fabrics, although they must be treated carefully to make the stencil bond to the fiber. Many suppliers have fabric selection charts which suggest the best fabric for the type of stencil and the printing application. They also provide charts which compare the mesh counts of the various multifilament and monofilament fabrics available to the screen printer. The screen fabric must be stretched in each direction across the frame so that it is tight and even. As a general rule, silk can be stretched 2 to 3% of its original dimensions in 4 directions, nylon from 3 to 6%, and polyesters 1 to 4%. Most fabric manufacturers recommend the use of a mechanical stretching system which makes it possible to control the exact amount of tension for any frame. The fabric to be stretched should be larger than the frame. The material should be centered over the frame so that the fibers run parallel to the frame edges. The screen can be attached to the frame with tacks or staples or by means of a cord pressed into a groove cut on each side of the frame. When possible, the fabric is fastened at the center of each of the 4 sides first and is stretched evenly toward the 4 corners. The screen should be drumhead tight without warps or tears in order to ensure good reproduction. Quality printing cannot be produced through a loose or defective screen. Fabrics must be cleaned and degreased before adhering the stencil. Some synthetic fabrics also need special treatment to help the fibers hold the stencil. To prepare synthetic or monofilament fabrics such as nylon and polyester to accept the stencil, the fabrics must be treated with a fine powdered cleanser such as 500 grit silicon carbide or a 10 to 20% caustic soda solution. The powder is poured onto a dampened screen and the entire screen surface is scrubbed thoroughly. The screen is then rinsed thoroughly with a strong water spray. This process must be repeated each time a synthetic fabric screen is used to roughen the threads and to provide enough fabric surface area that will adhere to the stencil. All screen fabrics must be cleaned and degreased before stencils can be adhered to them. Residual inks must be removed from screens that have been used before, using solvents recommended by the ink manufacturers. New and used screens should be dampened and scrubbed on both sides with a soft to medium stiff hand brush and solution. Scrubbing should continue until the fabric is completely degreased. The screen is then thoroughly rinsed on both sides with a powerful water spray and allowed to drain and dry. Once the screen has been cleaned and degreased, it should not be stored for a lengthy period of time before the stencil is adhered. Excess fabric should be trimmed away and the screen edges should be coated with finish sealer or shellac and dried to help retain the tension of the screen. Both hand-cut and photographic stencils may then be adhered to the screen. The subject of stencil production is broad enough to require coverage in a separate video cassette and therefore is not covered here. Once a stencil is adhered to the screen, craft tape is then moistened and applied to the outside of the frame. The inside is taped to exactly match up with the tape on the outside. On both sides, the tape should extend onto the screen itself about a ½ inch. This keeps the ink from the corners and grooves and helps in cleanup. The non-image areas that must not print can be blocked out with a masking material. Water-based or lacquer-based liquid masking material or blockout can be applied to the screen with a brush, a piece of cardboard or plastic, or a small squeegee. The type of blockout should be compatible with the type of stencil on the screen. If a water-based ink is to be used, the stencil and blockout should resist water to prevent the ink from breaking down the blockout and stencil. If an oil or lacquer-based ink is to be used, the stencil and blockout must be resistant to oil or lacquer solvents. More than one application of the masking material may be required to completely cover non-printing areas of the screen. One common problem in screen printing is the tendency of the substrate to stick to the screen after it is printed. The substrate must then be carefully peeled away. This slows the printing process and can result in smeared images. To prevent this, spacers can be used to raise the screen and stencil 1/16 to 1/8 inch above the printing material. Now the screen touches the stock only when the squeegee passes over it. As soon as the squeegee is passed, the screen snaps away from the stock, producing a much sharper impression. The consistency of the printing ink can also be a factor causing the substrate to stick to the screen. Once the proper spacing has been established, registration can be assured using several methods. One method is to place a piece of stock under the screen with the film positive taped to it. Alignment of the positive with the stencil will locate the position of the edges of the stock so guides can be placed to facilitate registration during printing. Another method uses a sheet of acetate to help with the location of the guides, and retractable guides are available which raise for positioning the sheet when the screen is up and lower when the screen is down. Ink for printing can be placed outside the image area. More ink can be applied as needed. A piece of stock is positioned against the registration guides and the frame is lowered into printing position. The edge of the squeegee is held at an angle as the ink is pulled across the image area with firm pressure on the squeegee. The screen is then lifted and the ink may be drawn back over the screen in a flood stroke, which leaves a deposit of ink in the image area and returns the ink and squeegee to position for the next pull. In this way, the image area is prevented from drying and plugging between printing, and a ready supply of ink is kept in the image area for the next print. Ink viscosity may be a factor when materials stick to the screen. Vacuum printing boards and spray adhesive are sometimes used to help eliminate problems of sticking to the screen. Freshly printed products are placed on drying racks until they are completely dry. This process is repeated until all required copies have been printed. When the printing operation has been completed, the screen must be cleaned to prevent the ink from drying and clogging the fabric. Excess ink can be removed from the screen surface and squeegee with a spatula or a piece of plastic. This ink can be returned to the ink can if no dryer or other material was added to the ink during printing. If there is any question of contamination, however, the ink should be discarded to avoid contaminating the remaining contents of the can. Used ink should be discarded following local, state, and federal regulations. If a paper stencil was used, it should be removed now. Paper can be lifted and peeled away from the screen without difficulty. Other stencils are removed after the screen has been cleaned. When cleaning the screen, it is important to use the correct solvent for the ink. Water for water-based ink, lacquer thinner for lacquer-based ink, or mineral spirits for oil-based ink so that the fabric can be thoroughly cleaned. A sheet of glass can be placed under the screen. Solvent is poured onto the screen and the squeegee is used to move the solvent around. Using the glass or some other non-absorbent base during cleaning minimizes the amount of solvent needed for cleaning. The screen is wiped with cleanup towels moistened with solvent for final cleaning. Safety containers should be available for used cleanup towels. Screen printing solvents and ink should be used in a well-ventilated area. The thoroughly cleaned screen can be stored for future printing, or the stencil can be removed so that the screen can be used for other printing jobs. Water-soluble stencils The glue from Tusha stencils and some indirect photographic stencils may be removed by holding the screen under hot running water. Special cleanup tanks are available to facilitate water-soluble stencil removal. Other photographic stencils must be dissolved by a special solvent recommended by the stencil manufacturer. Some can be removed with bleach. Lacquer film stencils are removed with lacquer thinner. A glass plate placed under the frame will facilitate stencil removal and minimize the amount of solvent needed for removal. A single sheet of newsprint or old newspaper is first placed under the stencil, and the stencil is saturated with solvent. The solvent will begin to dissolve the stencil, causing it to adhere to the newsprint. The newsprint is stripped away. Final removal and cleanup can be done with the squeegee, the glass plate, a small amount of solvent, and a wiping rag. Lacquer thinner evaporates rapidly, so it must be worked with quickly. Once clean, the screen should be stored vertically to protect the fabric. Handled with care, a screen can be used for several different stencils to print many thousands of impressions. Screen process printing is an old and time-tested method of graphic communication that commands a special niche among the commercial printing processes.